Hello everybody and welcome back to my channel. So there are a few orders of business I need to get out of the way. Good news, on my next paycheck I am getting a better camera, so I don't have to hold my phone and do these silly videos for you guys. They're not silly, but I feel silly doing them on my phone. So I'm getting a new camera. I can do my videos at my desk. There won't be as much shaking involved. So I'm really excited to get that, so my videos for you guys can be just that much better. Second order of business, I ordered this shirt online and it came in today, and I just want to share it with you guys because all you know, I'm a science nerd. So if you don't know who this is Neil deGrasse Tyson. That is DeGrasse. Look him up. He is wonderful. So it's just a plain t-shirt. It has one of my favorite scientists on it, and it says, "Maybe science will help." So I'm really excited to wear that. Anyway, let's get down to business. So I'm making this video because I've had a couple students in the past few days ask me how to balance a reaction using the half reaction method. We use half reactions in electrochemistry. And don't be scared by the word electrochemistry, because literally the batteries in my phone are driven off of electrochemistry. Any battery that you put into a calculator or a TV remote, that's all electrochemistry. And all it's doing is using chemistry to our advantage to create some sort of electric current using, surprise, electrons. So don't let that, that term scare you. But, so this equation that I'm given right here, I am told I need to balance it using the half reaction method. Even if I weren't told that I need to balance it using the half reaction method, I know I'm going to need to use the half reaction method because, as we can see on our reactant side, I have an oxygen over here, but oh wait, I don't. There's no oxygen over here. So I automatically know I will be using the half reaction method to solve this. Now, some professors, if you're given this on a homework set or an exam, they'll already give you the separate half reactions that are going on here. But I just don't know what your professor is going to give you, because I have seen it on an exam where you're given this and you're told to balance it using half reaction method. So I'm just going to start from ground zero. So the first thing we need to do is break these up into our separate half reactions. And all we need to do to break it up into our separate half reactions, we can see here that we have tin, which is SN, with 1 charge on this side, on the reactant side, and then we have tin with a 4 plus charge on the product side. So we're just going to match those up. That's going to be half reaction number 1. We have another one that has an iodine and an oxygen compound on this side and an iodine on this side. We're still going to match those up, and I'll tell you how to deal with the oxygen here in a little bit. So the tin is one separate reaction, and the iodine is a second reaction. So we'll say tin 2 plus, and it's going to go to tin 4 plus, and then we also have the iodine compound here going to another iodine compound here. Okay, so I like to start with my simplest reaction first. And to do that, first of all, I need to stoichiometrically balance these. Don't be scared by that word either. All that means is I need to make sure that whatever I have in proportion on this side is the same that I have in proportion on this side. So it looks like my tins are good. I have 1 tin over here, 1 tin over there. And so now let's move on to our iodine compound. Like I mentioned earlier, we have oxygen on this side, but no oxygen on this side. So in electrochemistry, all of this is going on in an aqueous solution. So it's not really going to hurt if I add H2O over here. But I have 3 oxygens, so that means I really need to have 3 H2O over here. But here's another hiccup. By adding water over here, we have in the process added 6 hydrogens, because we have 2 here and 3 waters, so 3 times 2 is 6. Not a big deal. We can just come over here and say, okay, well, now I have 6H plus over here. So now we're done stoichiometrically balancing. Now, the whole purpose in doing this half reaction method of balancing is to get them to cancel out and add up to our overall equation here, plus some water and some hydrogen. So in order to do that, I need to start keeping track of my electrons, because whatever is going on charge-wise on the left-hand side is going to be going on charge-wise in the right-hand side. So I need to figure out how my electrons are being exchanged in both of these half reactions. So an electron carries a negative charge. So if I'm going from a 2+ state here to a 4+ state here, that means I need to add in 2 electrons over here. And this is exactly what I was talking about. Your charges on the left add up to your charges on the right. So 4+, I have 2 electrons which have a minus charge, so 4+ plus -2 is +2. I only have a +2 over here. So we're good. We're good there. Now, with the second one, a little more difficult because we have iodine in a -1 state over here, but this number right here, this negative, that indicates the charge of the entire ion, but we want to figure out what it is for iodide, not the entire ion. So, just real quick to find the oxidation state of iodide, our oxygen here is always -2. This is the entire charge of the whole ion. So we want to make sure all of that we're adding it up equals -1. Just to be clear, I'm getting that -1 from here. I'm not getting it from here. I'm getting it from the charge on the ion itself. And since we have 3 oxygens and they're each -2, this is actually a -6 there. So now I need to figure out what's this quantity right here to make sure that entire ion is -1. Well, we just move this 6 over here, add the 6 in, and we find that that charge is +5. Now, our electrons that are being exchanged here, if we're going from iodide that's in a +5 state to iodine in a -1 state, how many electrons does that take? Whenever you're crossing over from positive charge to minus charge, you can't forget your 0. So we go from 5+ to 4+ to 3+ to 2+ to 1+ to 0. That's 5. I've run out of fingers. Down to -1. So there are actually 6 electrons involved in this. So we have +6 electrons. Now our goal is to get these electrons to cancel out. So, and I knew that this was on this side because eventually I want these electrons to cancel out. That's how I knew it was on this side. And that's why I start with the easiest one first, because if I can figure out which side the electron goes on here, then whatever it is down here is on the opposite side, because eventually we want these to cancel out because you don't see any electrons in our given equation here, so we don't need to have any electrons in our final equation. Okay, so this is pretty much just like the delta H. Now, if you're not sure what I'm talking about whenever I say delta H, go look at my video for Hess's law. It'll make sense. So we're going to run this in the same process as we would finding the delta H of 2 combined or 3 combined reactions. We need to get these electrons equal to each other, and then they can cancel out. So pretty much what I need to do is multiply all of this by 3, because if I multiply it by 3, then that means that will be 6 electrons there, and then I can cancel it out with the 6 electrons here. So that's what I'm going to do. I'm just going to go through and multiply everything by 3. That makes 6 electrons here. Since I multiply by 3, now I have 3 10s here and 3 10s here. Now, all we are doing is adding up these 2 half reactions. So our 6 electrons are gone on either side, and I'm going to draw a line down the center here. Everything to the left of that line is a reactant. Everything to the right of that line is a product. So I'm just going to write down all of my reactants over on this side. Got 3 SN2, I have a 6H, and I have IO3 minus. All right, so that's all of my reactants. Now let's move on to my products. 3SN4 plus I minus plus 3H2O. So just to kind of double check myself, because this is the final answer I have gotten out of balancing that with the half reaction method, but just to check myself, I'm going to go through and make sure that I have equal proportions of everything on both sides. So I have 3 tens here, 3 tens here. We're good. I got 6 hydrogens here, and 3 times 2 is 6, 6 hydrogens there. I have 1 iodine here, 1 iodine here. 3 oxygens here. 3 times 1 is 3. 3 oxygens there. So it looks like I am all balanced and I am ready to go. And thank you guys for watching this video. If you would like to see any more chemistry videos, or if you're having trouble or struggling with anything related to chemistry, just comment and I will do a video for you. Thank you.